So the last slide that I have discussed with you guys was satellites. Actually, देखें, जब हमारे पास, I have told you there are two ways to communicate. One is guided media, another one was unguided media. Fine, that was clear. अब हमने smaller से enterprise level पे जाना है, right? Let's suppose, sorry, when we are talking about a media or we are going to connect our computers inside a LAN, inside a local area network. अब local area network कहाँ है? हमारे घरों में, हमारी offices में, inside a same building. We discuss or we call it as a local area network, right? Inside a local area network, if we want to connect multiple sites, not multiple sites, but multiple computers or multiple nodes together, we have to use a copper media. ठीक है, ये मैंने चीज आपसे डिस्कस की थी कि उनको कनेक्ट करने के लिए यू विल नेवर गो फॉर एन ऑप्टिकल फाइबर. आपने अगर 2 कंप्यूटर्स को या 10 कंप्यूटर्स को स्विच के साथ कनेक्ट करना है, यू विल नेवर गो फॉर अ ऑप्टिकल फाइबर. कीप दिस थिंग इनसाइड योर माइंड. ठीक है, इफ एनीबॉडी आस्क्स यू दैट कि जी लैन में हम फाइबर ऑप्टिक यूज कर सकते हैं, नेवर. यस, इन सम सिचुएशन, लेकिन वो बहुत आगे की बात है कि आप स्विच को एक फाइबर कनेक्टर के साथ यूज करते हुए आप कर सकते हैं, लेकिन दैट इज ओनली फॉर अ स्मॉल पर्पस. वो हम यहाँ पे डिस्कस नहीं कर सकते. लेकिन द जनरल आइडिया कि अगर हमने, इफ वी वांट टू कनेक्ट आई मीन लोकल एरिया नेटवर्क, वी मस्ट हैव टू यूज copper cable, and copper cable might be a coaxial cable or a STP or UTP. Nowadays coaxial is no more be used inside LANs for to create a local area network. Nowadays only the cable that is being used is called as your STPs and UTPs. Right, so that is the first thing. अब हम आ जाते हैं, if we want to connect multiple sites, then what we have to use. अच्छा, एक बात ये आपने समझनी है कि when we are talking about a copper media or you may call it as a STP and UTP cable, इनकी range बहुत small होती है. I mean, what I mean by the range, how longer it will take that particular signal to transmit from one point to another point, right? Let's suppose maybe 100 to 200 or 300 meter range. इससे ज्यादा range नहीं होती. I mean, range का क्या मतलब हुआ कि after that particular range your signal is going to be degraded or your signal need finding some sort of attenuation, I mean certain sort of interruption. आपका signal जो है वो degrade होना शुरू हो जाएगा. ठीक है, the reason behind that, because the capacity of that particular media is only to take a signal or to transmit a signal between 100 to 200 meter. After that you need or you required what? You required the repeaters. Repeaters are the devices or the mechanism through which your signal is going to be remodulated, या हम कह सकते हैं कि उसको वो enhance होती है, उसकी जो capacity है वो repeat होने के बाद उसकी strength उतनी हो जाती है, and then it is again be capable enough to travel for next 100 or 200 meters in a normal condition, and after that it is also going to be degraded. Again you need another repeater over there. Fine, so that's all regarding how you are going to you are going to interact with the local area networks. अब अगर हमने, you have seen different sort of PTCL exchanges in Hyderabad. I mean, I'm talking about Hyderabad because everybody is from Hyderabad and they know the situation, right? Now let's suppose if there is a one exchange is in Qasim and one is in Latifabad, right? And we want to connect them, right? Do you think what type of media we require? Ultimately you have a question inside your mind that we might be connecting with the unshielded twisted pair or shielded twisted pair. No, because this type of media is only being used inside a local area networks. But when you are going to connect to multiple sites, मैं आपको WAN नहीं कह रहा, I'm not using the word WAN, wide area network. I'm just going to say that कि अगर हमने दो multiple sites को connect करना है तो we do have two options. Either we have to use the antennas, I mean wireless connectivity होनी चाहिए हमारे दो sites के दरमियान. The second option is the backbone connectivity. That is what you can call it as a optical fiber. Optical fiber is always being used to connect longer distance networks. ठीक है, let's suppose हमने कराची टू हैदराबाद दो स्टेशंस को कनेक्ट करना है. हमने let's suppose हैदराबाद टू हैदराबाद अगर दो डिफरेंट पोजीशंस हैं या दो डिफरेंट लोकेशंस हैं उनको आपस में कनेक्ट करना है, we have to use backbone link, that is called as an optical fiber link. The reason behind that is because for the longer distance we use such type of media which has the longer range. Optical fiber में आपका signal degrade नहीं होता because it always travel in the form of light, and you can transmit your signal using an optical fiber up to hundreds of thousands of kilometers. I mean, even not hundreds but thousands of kilometers. You don't require any type of repeater in between that particular transmission. I think you're getting right. अब ये चीज हमारी हो गई through optical fiber. Now see, as we know that the bandwidth of physical media is bit higher than the wireless media. अब ये क्वेश्चन, ये बैंडविड्थ का आपको आई थिंक नहीं पता तो मैं आपको रिपीट कर देता हूँ. बैंडविड्थ इज द कैपेसिटी ऑफ द लिंक टू send and receive the data during a particular amount of time. I mean the number of bits that are being passing in a particular amount of time through a particular area. That is what you can call it as a bandwidth. उस चैनल की कितनी बैंडविड्थ है, कितना डेटा एक ही टाइम के ऊपर फ्लो कर सकता है उस पर्टिकुलर मीडिया से. दैट्स व्हाट यू कैन कॉल इट एज अ बैंडविड्थ. अब मोस्ट ऑफ द टाइम यू पीपल हैव सीन दैट कि इफ योर कंप्यूटर इज कनेक्टेड विथ योर वायरलेस मोडेम एट योर होम, it will be giving you a different speed. But if you are going to connect your computer with a physical medium, I mean आप एक केबल जो है straight through केबल लगाएं अपने मोडेम के अंदर, and the second one you have to put it inside your computer, and then you will be getting much better speed rather than the wireless medium. अब उसका रीजन क्या है? बिकॉज द फिजिकल कनेक्टिविटी डज नॉट हैव एनी सॉर्ट ऑफ इम्पेयरमेंट और एनी सॉर्ट ऑफ एटीन्यूएशन ऑफ द सिग्नल. आपका डेटा जो है वो थ्रू एक पर्टिकुलर मीडियम के आ रहा है. बट व्हेन वी आर टॉकिंग अबाउट a wireless connectivity, might be you are sitting in one room and your modem is being placed in another room or somewhere outside of your home, and the signal that is being traveling between your modem and your computer might find certain sort of hindrances. I mean, the signal that is traveling from modem to the computer and computer to the modem might be passing through different sort of walls. I mean by striking different sort of walls, by different sort of hindrances like tables, chairs, or things like that. Definitely when it is going to strike with different sort of physical things, it is going to lose its strength. या वो क्या होता है, उसकी जो आपके पास strength है वो reduce होती है. And when the strength is going to be reduced, when it reaches to a particular destination, it does not have that particular capability that an other channel have or the other signal have. ठीक है, तो जो सिग्नल आपका एक फिजिकल लेयर आई मीन फिजिकल मीडियम के थ्रू ट्रेवल कर रहा है, आई मीन थ्रू अ कॉपर वायर और थ्रू अ फाइबर ऑप्टिक वायर, मे हैव हायर बैंडविड्थ देन द सिग्नल दैट इज बीइंग ट्रैवलिंग थ्रू अ वायरलेस मीडियम. इतना ज्यादा डिफरेंस नहीं होगा, बट देयर इज अ डिफरेंस, राइट? योर फिजिकल मीडियम वुड share a higher amount of bandwidth or higher amount of data, while your wireless signal or wireless signal might be showing a less amount of bandwidth or less amount of transmission and receiving of data, right? So this is very important. That's what the reason is. So most of the time when you are going to connect your let's suppose Pakistan, how the Pakistan is getting an internet connectivity. हमारे पास internet connectivity कहाँ से आ रही है? Have you ever thought how we are getting the internet connectivity? Ultimately, you people, I have told you in the previous class also, we do have an optical fiber connectivity between Pakistan and the other part of the world, right? From where the internet service provider जैसे होते हैं. Most of the time, what is PTCL? PTCL is an ISP, Internet Service Provider. We are connecting with the PTCL, and PTCL is going to provide us the internet connectivity. ठीक है, आपका modem चल रहा हो, आपका Wi-Fi आ रहा हो, but if the internet is not coming from the back end, this means that there is no use of that. आपका Wi-Fi तो connect कर रहा है, I mean you have the wireless LAN inside your home, I mean everything is working properly, you have a network, but you don't have the internet connectivity with that particular network. अब इंटरनेट कनेक्टिविटी कहां से आती है? अल्टीमेटली यू आर कनेक्टेड विद पीटीसीएल नेटवर्क, एंड पीटीसीएल इन टर्न्स कनेक्टेड विद सम सॉर्ट ऑफ इंटरनेशनल नेटवर्क हु इज गोइंग टू प्रोवाइड यू द इंटरनेट सर्विसेज, एंड वी आर गोइंग टू पे फॉर इट. आवर इंटरनेट पीटीसीएल इज गोइंग टू पे फॉर देम, राइट? सो दिस इज द होल सिनेरियो. अब होता क्या है कि वी आर गोइंग टू कनेक्टेड विद दैट पर्टिकुलर इंटरनेशनल नेटवर्क बाय यूजिंग अ मीडिया दैट इज कॉल्ड एज योर ऑप्टिकल मीडिया. ठीक है, जिसे हम क्या कहते हैं, ऑप्टिकल फाइबर, एंड दैट इज एन ऑप्टिकल फाइबर दैट इज अ हाई एंड मीडिया व्हिच इज गोइंग टू कनेक्ट our network with the international network, and we are going to access the internet connectivity by using that particular media for any reason during that particular time. If that particular optical fiber is going to malfunctioning or it is being not working properly, the whole network of the Pakistan or the whole network of the country is going to be down, and most of the time you have seen that you are not getting that much speed that actually you are going to that you want, right? What is going to be happen? अगर आप PTCL phone करते हैं, they are going to say that there is some problem with an optical fiber that is connecting Pakistan with the outer world, ठीक है, उसके अंदर कोई डिस्ट्रप्शन आ गई है, कोई इंटरप्शन आ गई है, व्हाटसएवर, वो कट डाउन हो गई है फॉर एनी रीजन, सो द टीम इज गोइंग टू overcome that particular problem. So once the problem is being resolved, you will be you will be getting the full bandwidth that you are actually getting, right? So that was the I mean physical link. अब अगर हम आते हैं कि जी आपका लेट्स सपोज इफ यू आर ओनली ऑन अ फिजिकल लिंक, आई मीन ओनली ऑन अ फाइबर लिंक, इट कुड बी द पॉसिबिलिटी इफ दैट लिंक इज गोइंग टू बी डाउन, देन वेयर you are you will be disconnected from the whole world for a 5 minutes or 10 minutes for a 1 day or a 2 day, and it will create a big loss for the country, because if you are disconnected from the internet from the whole world for a 2 or 3 or 1 week, definitely you may come up, you may know that we are our all banks are doing certain sort of business online, right? And we are connected with the whole world through that particular banks, right? तो अब अगर आपके पास ये disconnectivity आ जाती है, तो you do not have any business with the outer world, and you will be facing a lot of difficulties during that particular time. So to overcome this particular problem, we must have an alternative link, and that alternative link is satellite connectivity, राइट? एक तो हमारे पास हो गया फिजिकल लिंक। अब जो हमारे पास सेकंड ऑप्शन होता है ना कि दो नोड्स को आपस में कनेक्ट करने का, दैट इज व्हाट यू कैन कॉल इट एज अ सैटेलाइट लिंक, बट make sure this is very expensive. Normally you cannot go for point to point or a satellite link between two countries. If you want to access an internet using a satellite or something like that, so it is very costly, and you have to pay a lot of money for that, and it is not so easy to use a satellite link while to provide internet to your country people, right? The second solution, that is a cheaper solution that is being used, that is called as your to say that physical media, that is called as your optical fiber media. Anyways, so if due to any situation that optical fiber link is going to be malfunctioning or it is not working properly and you are not getting an internet connectivity, so what they are going to do, they are going to transfer that particular internet connectivity to that particular satellite or wireless link. So for that particular time, for a 1 week or 1 day or 2 day, up to until and unless that problem, that physical problem is not going to be resolved, your internet connectivity is being transformed to a satellite, and you will be getting that particular connectivity through a satellite, and that's why you are not getting that particular amount of bandwidth through a wireless that you are getting through a physical link or through an optical fiber. Now that is the background, right, that I have told you. Now come to a satellite, to say that slide, that is slide number 15, satellites for long distance transmission. What I've told you, for a long distance transmission, if you want to connect two different sites or two multiple sites, you have to use either you have to use the fiber optic or you have to use the satellite. Fiber optic तो physical medium हो गया, उसको आप छोड़ दें, we have discussed so far in the last few slides. But right now, if you want to connect two multiple sites at two different locations which are at a very long distance wirelessly, without any wire, you have to use the term satellite, right? What are satellites? Satellites transponders receives, amplify and transmit the radio frequency signal back to the ground. अब होता क्या है, if you can see this diagram, so in this particular diagram what we have two earth stations, जहां पे आपके पास सैटेलाइट डिवाइस जो होती है ना, आपने देखी होगी जहां पे लगी होती है, they are being called as the earth station. This is the first earth station or your ground station, that is another earth station. Let's suppose this earth station is in Pakistan, somewhere in Karachi, and this one is in the US, right? This earth station. अब होगा क्या, आपके पास सिग्नल यहाँ से निकलेंगे, I mean the signals are being coming out of this particular device that is called as an earth station, would be going somewhere at this particular satellite. ठीक है, अब satellites के बारे में आपको पता होगा, they are moving around the earth, right, and at a particular speed, right. अब मैं satellites के बारे में आगे चल के आपको बताता हूँ कि there are certain sort of geo, leo, meo, there are different types of satellites which are available inside, I mean which are rotating around the earth, right. So first of all you just have to understand the basic scenario कि काम किस तरह से होता है, ठीक है. यहाँ से आपके पास अर्थ स्टेशन से सिग्नल्स ट्रांसमिट, जो ट्रांसमिशन आपने करनी है, दे आर गोइंग टू बी ट्रांसमिटेड, दे आर नॉट सेंड डायरेक्टली टू द अनदर स्टेशन. ऐसा नहीं होगा कि आपने यहाँ से सिग्नल सेंड किया एंड इट इज बीइंग रिसीव्ड एट द अनदर सिग्नल, आई मीन अर्थ स्टेशन दैट इज बीइंग लोकेटेड समवेयर in another country. Why? What is the reason behind that? The reason is very simple. Your wireless signal is not so powerful that it can travel up to thousands of kilometers. ठीक है, वो इतना उसका ट्रैवलिंग वो नहीं होता कि वो जी thousands of kilometers यहाँ से लेके चाइना तक वो ट्रैवल कर सके, because there are so much impairments, there are so many hindrances in between, and your signal is going to be degraded, and it is impossible for a signal to reach to the destination with its full strength. So that is the main reason you are going to place in between a satellite. अब होता क्या है कि यहाँ से आपका सिग्नल जब ट्रैवल करता है, it will go to the satellite. Satellite has certain sort. Satellite is nothing, is not a simple satellite. It might contain certain sort of technical devices like transponders, transceivers, receivers, and all these things, right? Which are going to amplify your signal, which are going to send and receive your signals, and all these things are being placed inside that particular satellite, right? जैसे ही आपका सिग्नल यहाँ पे जाके रिसीव होता है तो यहाँ पे आपके ट्रांसपॉन्डर्स वर्क कर रहे होते हैं. देयर आर सर्टेन ट्रांसपॉन्डर्स व्हिच आर गोइंग टू रिसीव द सिग्नल एंड देन दे आर गोइंग टू प्रोसेस इट एंड देन दे आर गोइंग टू सेंड दैट पर्टिकुलर सिग्नल to an appropriate earth station that is being located somewhere another part of the world like China or USA. ठीक है, तो वहां पे जाके वो आपके पास रिसीव हो जाता है वो वाला सिग्नल. So this is how your satellite would be helping to transmit your signal from one earth station to another earth station inside the whole world. Okay, that is regarding the basic idea कि जी satellite work कैसे करते हैं. Secondly, do you know that there are weather satellites? There are a lot of satellites which are being rotating around the earth. Why they are being rotating? They are just being rotating to find out certain sort of information regarding let's take an example of GPS. GPS आपके पास क्या होता है, आपको पता है ना, ट्रैकर आपका होता है, and if your car is going out of the range, the car is going to be blocked through that particular GPS signals or something like that. ठीक है, तो वो क्यों होता है, वो आपका सारा सिग्नल से कनेक्टेड होता है through the satellite, and satellite is going to find that that particular object is going out of scope, and they are going to block or they are going to lock that particular device when it is out of scope. So this is what the different satellites, different companies or different countries have launched different satellites for different purposes, and they are going to get these purposes from those particular satellites. और satellite की एक life होती है, I mean for 3 years, for 5 years or 6 years, after that particular time there is no use of that particular satellite, that is going to be removed from the Earth's orbit, right? So anyways, that is regarding the basic information regarding the satellite. Secondly, if you want to cover the whole Earth with a satellite, do you think that a single satellite is enough to cover the whole, to give coverage to the whole Earth? No. If you think that you want to cover the whole Earth और the whole globe, जो हमारे पास एक जमीन है जो आपको नजर आती है, I mean if you want to give a full coverage to the earth, ऐसा तो हो सकता है कि we are going to launch a satellite that is only going to give us the information regarding Pakistan or regarding India or regarding something like China. But if you think there is a satellite who is going to give simultaneously the information of the whole world, right? So how many satellites are being required at a single time to give you the information regarding the whole world? You require 3 satellites to be launched in the space around the earth, and they are moving around the earth, and these 3 satellites simultaneously can give you the information of each part of the world at the same time. If you're going to launch one, it could be the possibility it will only give you the information regarding a particular area, जो वो area cover कर रहा होगा, ठीक है. Satellite at a single time cannot cover the whole earth, सारी की सारी अर्थ को एक टाइम पे कवरेज नहीं दे सकता, ठीक है. So for that reason, the countries like USA, China, or the world well-developed countries, they have their very strong satellites in the in the space, and they are going to get the information regarding the whole world, right? And we know that to cover the whole Earth, we need how much satellites? 3 satellites. So this is very important. You have to you have to understand this thing that कि अगर हमने पूरी अर्थ को कवरेज लेनी है at a single time, you must require 3 satellites to give coverage to the whole world, right? So this is regarding the basic idea regarding the satellites. Then we have the geosynchronized satellite placed in an orbit at 35785 kilometers to 2202 miles above the earth, that is exactly synchronized with the rotation of the earth. अच्छा, अब ये जो सैटेलाइट्स है ना, ये इतनी स्टेज या इतनी डिस्टेंस पे होते हैं, एंड दे आर एक्चुअली रोटेटिंग विद द स्पीड ऑफ द अर्थ. जिस स्पीड से आपके पास अर्थ मूव कर रही है ना, एट द सेम स्पीड दे आर बीइंग रोटेटिंग विद द अर्थ. From the ground it appears to stay at the same position at all the times. अगर ज़मीन से हम देखें तो वो एक ही पोजीशन पे होते हैं जिस पोजीशन पे आपको ज़मीन नज़र आ रही होती है, because they are moving at the same speed that the earth is rotating, right? Then we have the low earth orbit satellites, जिसको हम LEO satellites कहते हैं. They are being called as geo satellites, and they are being called as your low earth orbits. Rotates faster than the duration of the earth at 200 to 400 miles above the earth. Actually, these are the satellites which are being used for the communication between different sort of locations using the earth stations and between the two countries or between the two continents, ठीक है. इनकी जो distance होता है ना ज़मीन से, that is between 200 to 400 miles above the earth. They do not appear to remain stationary. They will never be stationary. They are moving, and but make sure they are moving faster than the earth, ठीक है. Low Earth orbit satellites arrays is a set of satellites communicating with each other and with Earth's surface, ठीक है. ये आपस में भी communicate कर रहे होते हैं, and they are also communicating with the Earth stations which are being located at somewhere on the Earth, right? So they are being called as LEO and they are being called as GEO, right? Then we have the microwave. What is microwave? Microwave is a type of signals or type of communication, electromagnetic radiations beyond the frequency range used for radio and TV. किसी radiation की जो impact होता है, it is very harsh, and some of the radiations are very low. I mean, they have very low impact, like X-rays. I mean, when someone is taking an X-ray, you are going inside, they are going to say that you go outside of the room because these rays are very dangerous. Why they are dangerous? Because the frequency of these particular rays are very much high, and actually the frequency is higher, right? Which the rays which are very much dangerous, their frequency is higher, so the number of cycles per second are much faster than with the normal frequency rays, right? So this is actually the basic idea behind the frequency, ठीक है. तो मैंने इसलिए आपको बताया कि आपको idea हो what I mean by the frequency, right? So electromagnetic radiations beyond the frequency range used for radio and television. I mean the frequency which are being used for radio and TV, उनसे भी ज़्यादा आपके पास इन electromagnetic radiations की frequency होती है. They are being called as the microwave, right? It can be aimed in a single direction. ये आपके पास unidirectionals होती हैं, right? And can carry more information than low frequency RF transmission. I mean, they can carry a larger amount of data from source to the destination rather than the low frequency radio frequency transmissions, right? So that's why they are being called as your microwave transmissions, जिसको हम कहते हैं, ठीक है. Then you have the infrared, right? Infrared, that is very much clear. Remote controls used with TV, etc. like uses IRs, inexpensive wireless communications, limited to a small area, convenient for portable computers. Most of the time you have seen that your air conditions are being managed through the remote controls. Your televisions are being managed through the remote controls. Now, what type of radiations which are going from your television to the computer, I mean to say that to the remote control, and from remote control to the TV, that sort of communication is called as, or that sort of rays are being called as infrared rays, right? They have the less frequency and they are normally not so much dangerous, right? So I think that is clear to all of you कि microwave और infrared आपके पास क्या होती हैं, ठीक है? Now we can this is our new topic, that is local asynchronous communication, that is called as your RS232. Make sure these are the concepts which are associated with the data communication. Until and unless you are not clear with these concepts, you cannot understand actually how the computer networks is going to be implemented. Okay, so computers use binary digits like zeros and ones to represent data. We all know that. Your data is always being processed in the form of zeros and ones. We know that. Computers communicate by sending bits through a transmission medium, through cable or an air, I mean through guided or unguided media. Computers are going to send information in the form of bits. This chapter describes how electrical current is used to send digital information across a short distance, right? So the need for asynchronous communication. In asynchronous communication, the sender and receiver do not need to coordinate or synchronize before the transmission begins. I told you, in a synchronous transmission, what is going to be happen? Your sender and receiver are in line. They have to send certain bit of signal that I'm going to send the data. You have to receive the data at a particular amount of time and in this particular format. This sort of communication is being called as synchronous, in which your sender and receiver are both in line and are in contact, and they know that sender is going to send the data with this amount of bits and your receiver is going to receive the data at this amount of bit or something like that. This sort of communication is being called as your synchronous communication. But when we are talking about an asynchronous communication, you will not have any prior connectivity or any prior synchronization between sender and receiver. Sender can send the data at any time and receiver is going to receive the data at any time, right? So this sort of communication is being called as your asynchronous communication. They are not in coordination with each other. In an asynchronous system, the receiving hardware must be ready to accept and interpret the signal whenever it arrives, right? Whenever it arrives, I mean किसी भी वक्त आपका signal receive हो सकता है receiving end के ऊपर during the asynchronous system transmission. But when we are talking about a synchronous communication, you must have your sender and receiver must know that at what time your data would be sent and at what time your data has to be received, right? So using electrical current to send bits, a smaller electrical current is used to encode data. Example is negative voltage to represent a 0 bit, a positive voltage to represent a 1 bit, right? So vice versa also. I mean either you can have a negative voltage with 1 and a positive voltage with 0, or a positive voltage with 1 and a negative voltage with 0. You can use both of them, or your system can use both of them to represent a bit higher bit and a lower bit, right? So this is how you are going to represent the voltage in terms of zeros and ones. I think you are familiar with these terms. These are very generalized terms, right? ये आपके पास टाइम है, ये वोल्टेज है, नेगेटिव है, ये पॉजिटिव है. जो आपके पास नीचे आ रही है, जो वेव आ रही है, that is going to be represented by 1 and the upper one is going to be represented by 0, and a 0 voltage means there is no high and low value, right? Then standards for communication. Standards specify both the timing of the signal and the electrical detail of voltage and current. RS232-C by EIA. Now make sure this is in standard. RS232-C is in standard, is one of the most widely used standard to transfer characters between a computer and a devices such as modem and keyboards. I mean all the peripherals which are being connected with your computer, certain sort of bits or data might have to be transferred from your central processing unit to the devices and from the devices to your central processing unit. That has to be managed by your RS232 or ES standards. RS232 defines a serial bits are sent one after another, that is called as an asynchronous communication. You people have an idea of serial and parallel communication. In a serial communication, you might have data is being traveled in the form of bits one by one, and in the parallel type of communication, your data is being sent in the form of chunks or in the form of bytes. At the same time, multiple bytes of data are going to be sent. But when we are talking about a serial communication, you might have data that is being sent in the form of bits, right? RS232-C specifications might be used. I mean, in what communication that particular standard might be used. You might have a cable length that is less than 50 feet, right? You have a negative 15 volt that is going to represent 1 bit, and plus 15 volts that are going to be represent 0 bit. One character is equivalent to 7 or 8 data bits. No delay between character bits, there must not be any delay. When idle, I mean when there is no data to send or no data to receive, put minus 15 volts or bit 1 on the wire. I mean if there minus 15 volt 1 bit on the wire, this means that your transmission medium is idle and there is no any data to be sent and received. Each character start with the start bit 0 and end with a stop bit 1. I mean how you are going to recognize that your data is being start sending and stop sending. Your character that would be starting with 0, this means that your start of the bits has been started, and when it is going to be end, it is going to be represented by a bit value 1, right? Then you have the term that is being called as your baud rate, framing and errors. What is the baud rate? Baud rate is the number of changes in the signal per second. That is what you can call it as a baud rate, right? For simple RS232 baud rate, a number of bits per second, right? I mean, how can you define the baud rate if somebody asks you that? Number of bits per second. If the voltage measurement do not all agree, or if the stop bits does not occur exactly at the same time expected, framing errors are going to be occurred, right? So this is what you can you are going to define certain sort of baud rates. Then we have the full duplex asynchronous communication. I mean full duplex as well as asynchronous communication. Electrical circuits requires at least 2 wires. One of them to carry the data signals and the other one is used as the return path, that is called as ground. I mean for the full duplex communication you can send and receive the data at the same time. That's what the definition of full duplex communication. Simultaneous transfer in 2 directions are known as full duplex transmission. I think that is clear to you guys कि एक ही टाइम के ऊपर आप डेटा सेंड भी करें और रिसीव भी करें, उसे हम क्या कहते हैं? फुल डुप्लेक्स कम्युनिकेशन. एंड देन यू हैव द हाफ डुप्लेक्स जिसमें आपके पास सेंड कर सकते हैं, रिसीव नहीं कर सकते एट द सेम टाइम. दिस इज व्हाट यू कैन कॉल इट एज हाफ डुप्लेक्स कम्युनिकेशन. नाउ you can see this particular diagram, slide number 28. You can see clearly you have the data that has been, this is TR, transmission and receiving, right? T is going to send the data that is being received at the receiving end, and the other object is going to send the data and that is being received at the receiving end, right? This is how your data is being sent and received, and this is the ground line that is between the sender and the receiver. This is a full duplex asynchronous communication, right? So long distance communication, or you may call it as a, okay, this was regarding the communication that we can come across within a smaller distance. I mean अगर हम बात करें computer to computer communication inside a LAN or between your computer and a peripheral devices, we do have a smaller distance communication. We might be using RS232-C specification or full duplex asynchronous communication, right? But when we are talking about a long distance communication, what we have to use? For a long distance communication, electrical current becomes weaker as it travels over the copper. Signal loss occurs when RS232 is attempted to use to communicate to remote sites. A continuous oscillating signal called a carrier propagates farther than the other signal. अब देखें, जब हम एक स्मॉलर नेटवर्क की बात करते हैं वहां तक तो ठीक है, आपके पास ये वाली कम्युनिकेशन पॉसिबल है RS232 वाली. लेकिन if you want to communicate with the same signal for a longer distance, what you have to do? You cannot do the long distance communication by using RS232 standards, right? Your signal is going to be lost, your data is going to be lost during this particular communication. ठीक है जी. Now to overcome this particular problem, we do have the concept of modulation. I think yesterday I have discussed with you this concept, but again in detail I'm going to discuss with you. Modulation, okay, आप एक काम करें. In the meantime it is 9:50. You start punching out your attendance. ठीक है, मैं लेक्चर ले रहा हूँ, आप अटेंडेंस पंच आउट करते जाएं, बट काइंडली डू नॉट मैसेज मी. ठीक है, मैसेज की वजह से मैं डिस्ट्रैक्ट हो जाता हूँ. तो यू जस्ट पंच आउट एंड फाइनली व्हेन आई एम गोइंग टू एंड द लेक्चर यू हैव टू टेल मी दैट सर वी हैव डन विद दैट, राइट? सो to modulation is the process to send data. A transmitter slightly modifies the original information by using a carrier. Such modifications are called as modulation. The receiver monitors the incoming carrier, detects modulation, reconstruct the original data and discard the carrier. Now try to understand the concept. आपके पास एक सिग्नल होता है और दूसरा आपके पास क्या होता है, कैरियर होता है. कैरियर इज अनदर टाइप ऑफ सिग्नल हु इज गोइंग टू मॉड्यूलेट योर ओरिजिनल सिग्नल. अब होता क्या है, एक सिग्नल जिसने ट्रांसमिट होना है, ठीक है, it has to be overlapped over a carrier signal and that signal is going to increase the strength of the original signal, or you may call it as a modulate it. हम इसको क्या कहते हैं, modulate कहते हैं. To send data, transmitter slightly modifies the original information by using a carrier. आपका जो original signal है it is going to be modified by using a carrier. ठीक है, उससे क्या होता है, what is going to be happen, आपके signal की strength increase हो जाती है. ठीक है, and this procedure is being called as your modulation. At the receiver end, what is going to be happen? You monitor the incoming carrier. आपके incoming carrier को monitor किया जाता है. Detects modulation. चेक करता है आपका रिसीवर कि जी मॉड्यूलेशन आपके पास कहाँ पे हुई है. Reconstruct the original data. I mean अब आपका जो carrier है that is no use of the receiver. There is no use of that carrier into for the receiver. वो उसको अलग कर देता है आपके पास कैरियर सिग्नल को, एंड ओनली द ओरिजिनल डेटा दैट वाज बीन सेंट फ्रॉम द सेंडर इज हैज टू बी रिकंस्ट्रक्टेड एंड डिस्कार्ड द कैरियर. दैट कैरियर हैज टू बी डिस्कार्डेड. ठीक है जी, इज दैट क्लियर टू ऑल ऑफ यू दैट हाउ मॉड्यूलेशन इज गोइंग टू बी अकर. अब मैं आपको बताऊंगा कि मॉड्यूलेशन आपके पास कौन सी डिवाइस करती है. ठीक है, देन टाइप्स ऑफ मॉड्यूलेशन, देयर आर 3 टाइप्स ऑफ मॉड्यूलेशन. यू माइट हैव द एम एम्पलीट्यूड मॉड्यूलेशन, यू माइट हैव द फ्रीक्वेंसी मॉड्यूलेशन एंड यू माइट हैव द फेज मॉड्यूलेशन. एम्पलीट्यूड मॉड्यूलेशन में क्या होता है, आपके पास एम्पलीट्यूड ऑफ द सिग्नल इज गोइंग टू बी इंक्रीज, योर फ्रीक्वेंसी एंड फेज रिमेन सेम, right? Your frequency and the phase remain same. Your amplitude is going to be increased or decreased depending upon the situation. That type of modulation is being called as an amplitude modulation. Second one is called as your frequency modulation, in which your amplitude and phase remain constant. Your frequency is going to be varied, right? Frequency का मैंने आपको बता दिया था, amplitude का आपको पता है. The distance of the signal from the x-axis to the top of the signal is called as your amplitude, right? Frequency आपके पास क्या होती है? The number of cycles per second is called as the frequency, right? So if your frequency is going to be varied, your amplitude and phase remain same. This is what you can call it as a frequency modulation. The third one is called as the phase modulation. Phase is actually being called as your angle of the signal. So when your amplitude and frequency remain same and your angle of the signal is going to be modified or is going to be modulated or is going to be increased or decreased, such sort of modulation is being called as the phase modulation. अब इसकी डिटेल बहुत लंबी है. You need to understand the datacom for this particular subject, but right now we just have to understand the concepts. So amplitude modulation होती है, frequency होती है और phase modulations होती है, और वो किस तरह से होती हैं, you just need to understand this, right? Then we have the device that is being used for this particular purpose is called as your modem. Modem, everybody knows that, you people are very much familiar with the modem that are being installed at your computers. A modulator is a hardware circuit that accepts a sequence of data bits, applies a modulation to a carrier wave according to the bits. A demodulator is a hardware circuit that accepts a modulated carrier waves and recreates a sequence of data bits. A modem is a hardware that combines both modulator and demodulator in a single device. अब होता क्या है, very simple words में आपको समझा दूं मैं. modem आपके पास दोनों साइड्स पे लगा होना जरूरी है, आपके कंप्यूटर के अंदर भी और somewhere else जहां पे आप भेज रहे हैं. तो आपके कंप्यूटर के अंदर क्या होगा, your data is going to be modulated and sent over the transmission media. तो modulation होने के बाद आपके signals transmit हुए, and when it is being received at the receiver's end, again the modem is there, it is going to demodulate the same data and the original data would be sent to the receiver. So modulation and demodulations are going to be performed parallelly by a single device that is called as modem. ठीक है जी. अब आपके पास आ जाता है एक न्यू कॉन्सेप्ट दैट इज आल्सो मल्टीप्लेक्सिंग. आई मीन दीज आर द कॉन्सेप्ट्स दैट यू मस्ट नो बिफोर लर्निंग दिस पर्टिकुलर सब्जेक्ट. मल्टीप्लेक्सिंग इज व्हाट, हाउ कैन 2 or more signals can be transmitted simultaneously over a single wire by using a different carrier frequency. अब देखें, let's suppose if you have 4, 5 or 6 signals and we want to transmit them over a single frequency or over a single transmission medium, we do have a concept. That concept is being called as your multiplexing. Now what it is? Carrier frequency and multiplexing. Frequency division multiplexing, or you may call it as FDM, using multiple carrier frequencies to allow independent signal to travel through a medium. अब देखें इस पिक्चर के अंदर आपको समझ आना जाना चाहिए कि you have sources, आपके पास 3 सिग्नल्स आ रहे हैं and we want to combine them into a single over a single transmission media. So what we have to do, we have to put a multiplexer that is called as MUX एट द सेंडर। वो क्या करेगा, इन तीनों सिग्नल्स को या 300 सिग्नल्स को कंबाइन करेगा और एक ही मीडिया के ऊपर सेंड कर देगा। दिस इज व्हाट यू कैन कॉल इट एज अ मल्टीप्लेक्सिंग, राइट। दिस इज अ शेयर्ड चैनल। और रिसीविंग सिग्नल के ऊपर, रिसीविंग साइड के ऊपर क्या होगा, यू हैव द डी मल्टीप्लेक्सर, इट इज गोइंग टू रिसीव द सिग्नल एंड इट इज गोइंग टू replace that particular I mean divide that signal into the original signal। I mean अगर 3 सिग्नल्स यहाँ पे रिसीव हुए हैं इन अ सिंगल फॉर्म, तो वो आपके पास 3 में डिवाइड करके इंडिविजुअल डेस्टिनेशन तक पहुंचा देगा। दिस इज हाउ योर मल्टीप्लेक्सिंग एंड डीमल्टीप्लेक्सिंग is going to work, right? I mean, if a multiple signals are being sent over a single media, this is what you can call it as a multiplexing। And when these single signal are going to be divided into a smaller signal, into an original signal, that is what you can call it as a demultiplexing, right? So there is a different types of multiplexing. One is called as frequency deviant multiplexing, wavelength deviant multiplexing and time deviant multiplexing। अब frequency deviant multiplexing इसको आप समझ लें, मैं आपको डिटेल नहीं बता रहा इसकी इंग्लिश में, आपको जस्ट ये बता रहा हूँ कि WDM is same as it is like the frequency deviant multiplexing, but the difference is frequency deviant multiplexing acts on a signals, electrical signals, और wavelength deviant multiplexing is works on an optical fiber, I mean in the form of light। जो आपके पास डेटा या सिग्नल्स इन द फॉर्म ऑफ लाइट आ रहे हैं या जो ऑप्टिकल फाइबर के थ्रू ट्रांसमिट हो रहे हैं, उनके ऊपर जो आपके पास मल्टीप्लेक्सिंग हो रही होती है, दैट इज कॉल्ड एज योर वेवलेंथ डिवीजन मल्टीप्लेक्सिंग एंड सेम लाइक योर frequency deviant multiplexing, right? And the third one is called as your time deviant multiplexing। Source sharing a medium take turns to send data। Synchronized TDM gives each source an opportunity to send the data। Statistical TDM does not give chance to a source that does not have data to send। I mean TDM के अंदर आपके पास जो multiplexing हो रही होती है, it is based upon your time slicing। I mean over here your time is being used to multiplex your signal and to send over the network। So these are the three types of multiplexing: frequency division, wavelength division, and the time division multiplexing। So that is all for today.